Find the area bounded by the curves y equals x over quantity x squared plus 1 and y equals negative 1/2 x squared from negative 1 less than or equal to x less than or equal to 1. Okay, so, man, this is, So I have no idea how to graph that. So normally go straight to my, I usually avoid using my calculator to just graph things, and I try and get some mental intuition before I plug things in my calculator. The reason for that is it's really easy to get confused and punch things in wrong. X over quantity x squared plus 1. And if you have a mental picture before you start plugging things into a calculator, then you'll have a better idea of when you make a mistake. And so I try to avoid my calculator not whenever possible, but I try to minimize the use of it. For this one though, I look at this, I'm like, yep, no idea. This is probably a harder problem than you would normally get for a x squared AP exam, but it would be maybe the sort of thing you'd get during a free response or some sort of variation of this. Because the only reason you really wouldn't get a problem like this on the AP exam, at least on the multiple choice section, is you really can't solve this in 3 minutes. Even if you look at it, it's like, well, some AP questions will take 2 minutes, some will take 4, for the calculator section. This would be really challenging to solve it even in 4 minutes. You're talking about just a minute just to put in your calculator. Okay. Hop, 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 hop. Okay. And we'll see what the Wolfram says. Computing. And okay, so we're doing it from negative 1 to 1. So from here to here. And so the 1/2 x squared negative is going to be bigger from negative 1 to 0, but then it's going to switch on which one's bigger. So we're going to have to do this in 2 portions. So we're going to do 2 integrals here. So we'll go from negative 1 to 0, and then from 0 to 1. And this will be negative 1/2 x squared minus x over x squared plus 1. And then we're going to have to do a substitution just to get this one done. So this is going to be a little bit more in-depth than you would in just for an AP multiple choice question. Okay, so this is going to be the first portion. So we take the area under this curve, subtract the area under that curve. Ooh. Maybe. Yep. And then for the second curve here, we're going to do the, let's see, the blue. So we're going to reverse the 2, which ones we subtract. So the second one will be x over x squared plus 1 minus negative 1/2 x squared dx. And one quick thing to explain is you're thinking, all right, how do I know, do I subtract the top one from the bottom one, or do I subtract the one that's furthest away from the axis from the other one? So it's like, all right, should we subtract this 1/2, negative 1/2 x squared from this, or is the other way around? And the mathematical way to look at this is we're trying to find the area between the curve. So we want a positive number. And so what we're going to do is we're going to find the area under this curve for the red line, and we'll get a negative number because this is a negative area. But then we'll subtract from that a more negative area, the x over quantity x squared plus 1. And when we subtract so we take a negative number and we subtract a bigger negative number from that, we're going to end up getting a positive value. Long story short, when we do this integral, we need to make sure it's positive. Okay, and then we had to break it up into 2 parts because the bigger fraction, the bigger, integral switches at 0, at point, the x equals 0? No, yes, x equals 0 point, right here. No, it sounds confusing. Hang with me, we got this. Okay, back to the maths. Whoop, let's do some green. So we have I'm going to find out what this is real quick. So integral of x over x squared plus 1 dx. This gives us, we'll say u equals x squared plus 1. Du equals 2x dx. Therefore, du over 2 equals x dx. Okay? Not too unreasonable. And so we're left with integral 1 over u, 1 over 2u du, which gives us 1 over 2 natural log of u, which equals 1 over half natural log of x squared plus 1. Okay. So that will be the integral for that portion right there. So putting everything together, I'm going to rewrite this. And we have negative 1 to 0 of, let's see what the integral of this is real quick. So we have negative 1/2 x squared. That will be negative 1/2 x cubed over 3. Yeah, I'm good with that. So we'll have negative x cubed over 6, because 2 times 3, minus 1/2 natural log of x squared plus 1. Okay? And I'm going to get rid of the integral sign there because we just took the integral already. And this will be evaluated from negative 1 to 0. And then we will add to this, there we go. We have 1/2 natural log of x squared plus 1. And normally these are absolute value signs here, but x squared plus 1 will always be greater than 0, so we don't have to worry about that. Natural squared x squared plus 1 plus minus plus x cubed over 6. And this will be evaluated from 0 to 1. Okay? And I'm going to switch these limits of integration around. That way we're just working with positive numbers. I like to stay positive in life. There's already enough negativity out there. We don't have to add to it. 0 to negative 1. And then plus 1/2 natural log x squared plus 1 plus x cubed over 6. 0 to 1. Okay? Okay. Now we can bring this home. Man, this is definitely a longer problem than you'll see on a multiple choice section of an AP exam. So we have negative 1/6 plus 1/2 natural log of 1 plus 1, which will be 2. Because negative 1 squared, it will be positive 1. And then we'll do the 0 minus 0 cubed over 6 will be 0, plus 1/2 natural log of 1, which will be 0. So this will be 0. The 0 section goes to 0. So we can just get rid of all that. Plus 1/2. Now we're going to do the 1 over here. So we'll plug in 1, which will give us natural log of 2 plus 1/6. Minus, plug in 0, get 1/2 a natural log of 1, which is 0, plus again 0. So all we're left with then is natural log of 2 minus 1/6 plus 1/6 right here, which gives us natural log. That turned out surprisingly simple. So let's see if that's a possible answer. And it looks like it is. That's good. Whoop. Right there. So that was quite the journey. More than I anticipated at the beginning of the trek. Should have packed more provisions. But we got through it. So the idea here was, going back, we have 2 graphs. They're kind of complicated, so I had no idea what they were. I just graphed them. I gave up really early. Whoop, whoop. Fish or cut bait, immediately cut bait, and we graphed them, we found out that, all right, between -1 and 0, the second equation is bigger. But between 0 and 1, the first equation is bigger. So we always did the bigger equation, bigger as in more positive, higher on the y-axis. So we did the bigger equation minus the smaller equation, integral to find the area under the curve. Then we had to do a little bit of substitution to solve one. The other one was just the power rule. We got a natural log involved. We plugged in our numbers and we then kind of had like 4 sets of equations we had to solve. We kind of stumbled our way through them, and eventually we finally got down to an answer of just natural log of 2, which was really nice. And so then that will be our final answer, natural log of 2. Hope this problem helped you a little bit. Hoped you gained a little bit from it. No, I did. That was more than I anticipated. Thanks for joining me. I will see you on the next problem.